really need to realize that there's two relationships, and in order to get the one that you want, and they're asking for what the rate of change of z is at a specific instant, in order to get that rate of change, you need to use both relations. So the first one that you should see is that this one's a little tricky. So this point right here, they tell you that point right there is 0 comma 2, and you know that because it says the eye level point is 0 comma 2. This is the person watching, so you know that that point is 0 comma 2. Now you have that uh, you want to find out essentially the rate of change of this length, and this length, let's call it z, right? Now the rate of change of that length is what? Well, what's the equation for that length, right? This is a point, and then this is some other point, x comma y. Now you know a little bit more about this point here, but if we do this in the abstract, right, what is this length? It's just the distance between this point and this point. So what is the distance between this point and this point? Well, the distance formula between any 2 points is x2 minus x1 squared plus y2 minus y1 squared. And now that's this length, that's the distance, that's z. So we want to do z, but we actually know one of the points, but the other point is any point. So we leave that x comma y. So I'll make it that x2 is this any value, this value that's changing as the Ferris wheel turns, or it could be turning in the other direction, probably is. It is turning in the other direction, but anyways, yeah, as it turns in this direction, that xy point is changing. But the eye level that this person's watching, whoever it is who's watching, Jalen, this is Jalen, and they're watching Ashanti in the Ferris wheel cart. This is Ashanti over here, and this is Jalen, and they're watching, and Jalen's staying still, but Ashanti's moving in this cart around the Ferris wheel. And the point for Ashanti is x comma y, but the point for Jalen is 0 comma 2. So it's x minus x. It's x2, which is just x, minus this x value is 0. So it just becomes x squared in this case, plus, because it's x minus 0 squared, which is just x squared. Then it's y minus, and then the y value is 2 squared. And this gives you this distance z as this point xy goes around. And what you're looking for in this case is you're looking for dz dt. And when you differentiate this function, we have to be careful, okay? So this is the same thing as this whole thing to the 1/2. So this is the same thing as x squared plus y2 minus y minus 2 squared, the whole thing to the 1/2, right? So I bring down the 1/2. It's x squared plus y minus 2 squared to the negative 1/2 times the derivative of this inside. So I'm doing chain rule, right? This is the inner function, this whole thing right here. And then the outer function is to the 1/2. So I brought down the 1/2, and then I minus the exponent by 1, and I got this. But now I have to differentiate the inner function. And this is all with respect to time. So the derivative of x squared with respect to time is going to be 2x dx dt plus the derivative of this, y minus 2 whole thing squared, is 2 times y minus 2 times the derivative of the inside, which is just dy dt. And now this here is an expression for dz dt. And if you look, so I have dz dt, I'm going to write it so it's a little bit more clear over here. if you look, I have here, I'm going to have 1/2, and if you like, maybe to make this a little bit more simple, this is going to be x squared plus y minus 2 squared, right? And that just stays on the bottom, and then on the top I have this, the 2x dx dt plus 2 times y minus 2 dy dt. And I can actually factor out a 2 and cancel out a 2 if you look, if I factor out that 2. And I now get a cleaner expression for dz dt, which is x times dx dt plus y minus 2 times dy dt over the square root of x squared plus y minus 2 squared. Okay, and now we're looking for this at a particular time, a particular instant. So it's when x is 15. So I have x. So let's see what I have in this here. So I have x because they tell me x is 15. Then dx dt, they tell me, yep, dx dt is 1. I have that one. Then I have y. I have this missing variable here. I have an x already. I have this y. That's good. But now it's dy dt that's still missing. And that's where it is that this other relationship comes into play, where essentially we use the fact that this Ferris wheel is this is a Ferris wheel, and it's a circle. So you have the equation of a circle right here, and you have the center for this circle right here. So I have that there's also a relationship. So I have x minus 12 because the center is 12. So this is the equation of a circle right here. So the equation of the circle that I have is x minus 12 squared plus y minus 7 squared is equal to the radius squared. Now you could solve for the radius. The radius is 5, but it really doesn't matter because it's a constant. And what you're going to do is you're going to differentiate this entire relationship with respect to t. So you can solve for dy dt, because the only thing that will be missing is going to be dy dt. So you're going to get 2, because this is the inner function, x minus 12 times dx dt, the derivative of that inside, right? So I brought down the 2. The derivative of the inside is just the derivative of x with respect to time, which is dx dt, plus 2 times y minus 7 times dy dt. And then the derivative of the constant 25, or 5 squared, is 0. Now I have everything in this, right? I have x is 15. So 15 minus 12 is 3 times 2. And dx dt is 1 plus 2 times y is 11. 11 minus 7 is 4. And then I have dy dt has to equal 0. And this is going to give me 6 plus 8 dy dt equals 0. 6 plus 8 dy dt equals 0. And this will, when I solve for dy dt, take your time, gives me negative 3/4 for dy dt. And now if you go back to dz dt, now I have dy dt as well. I can plug in all the missing values and I will get dz dt. Take your time with the computation. A calculator is allowed on this question. Okay? And when you use the calculator, what you'll get is approximately a positive value of 0.47. So now you would just plug in, right? dz dt is going to be equal to, okay, x is 15, dx dt is 1, plus y is 11 minus 2 is 9, times this dy dt that we just solved for, negative 3/4, over the square root of 15 squared is 225, plus 9 squared is 81. And you'd get the square root of 306. 15 plus whatever this is. I mean, take your time. Minus 27 over 4. Find out what this is. What you'd get is that it's approximately 0.47 meters per second, and C will be the answer. Again, a calculator is allowed for this. Take your time with finding out what dz/dt is after you plug everything in. The key here was those two relationships. There was first you use the distance formula for z, because z is essentially the distance between Jalen's eyes, the eye level, and this Shanti's car. And then the other relation that we needed to use to get dy dt was the fact that this is a circle. This point xy is always satisfying the equation for a circle with center 12, 7. And using those two things, you can solve for the rate of change of z.